Okay. What? The test?
Yeah, like, do we have time to figure it out?
Oh, that's part of your calculation. Do I have time to get up this hill? Yeah.
We're gonna do it all together. Yeah.
Oh, somebody's just gonna count. So that's the problem. That question, obviously, if I put that question first, then you're on the sixth page. So I don't do that. I put it at least second. But I like to put it later so everybody gets into it at a different time.
Question 20. So whoever gets
Next week.
proceeds to do the that starts like the Victor question. Hey guys, question number 17.
So, I don't know if I'll be able to do three-dimensional. I wanted to do vectors in two-dimensional and three-dimensional, so you kind of have a head start in Calc 3. If I can do 3D, I'll try it, but for the most part, it's my job to teach you 2D vectors. So, here we go. As we just heard from our friend, it's a mathematical quantity, if you like, but it is idea that it's both direction and magnitude. A vector can be expressed three ways. We will use all of them interchangeably. The vector u, now in textbooks, vectors are often bold. It's hard to write bold in your handwriting. So when you write vectors on your paper, you will use the common arrow over the top, okay? But when you read a textbook and you read a bold letter, that indicates a vector, okay? You often talk about I hat plus j hat, where I hat is the unit vector of one unit in the horizontal direction, and j hat is a vector of one unit in the vertical direction. If you then multiply those by an a or b, those are called scalars, then that stretches the vector to some other length besides one. You with me? Likewise, you could, so if I were to graph this, you would say A and B are the vertical components, so the combination of the two, this is U. U is a combination of horizontal and vertical vectors, giving me the vector U. Sometimes you will do that in a different component form. Instead of I hat, j hat to designate horizontal movement, you'll see these pointy brackets. Anytime you see these are vectors. You will sometimes see, instead of A and B, you'll say I hat, J hat, and K hat. That's three-dimensional, sorry. K hat is the third dimension vector if you go there. Okay? If, let's do one in polar. So if you show a vector in three dimensions using the right-hand rule, this is the x-axis, this is the y-axis, this is the z-axis. If you want to show a vector, then you really draw a box around it. Say I wanted to sketch the vector 2, 3, 4. Then by just putting a point in space, we talked about this earlier, this is not at all clear where that's going, okay? So it's far more common that you would draw a box around it that is 2 by 3 in the denominator, or sorry, in the base, and then 1, 2, 3, 4 up from each of those points. 1, 2, 3, 4 up. 1, 2, 3, 4 up. 1, 2, 3, 4 up. So that you get this box in space to show that that vector is really the diagonal going from one corner of that box to the other. That's more common when you show vectors in 3 space. Then you draw a box around it, because otherwise the arrow's just too hard to tell where it's going. All right? If, do I come to that later? Yes, I do. Okay, I just want to make sure. Polar form is more of the idea of r at an angle of theta. where r is the magnitude of the vector, the length of the vector, and the notation for that is double bars. So if I said, for example, what is given, say I said vector v is this, and then I asked underneath it, what is this equal to? That is the length of the vector, the magnitude of the vector, which is like the hypotenuse. And so you'd say the magnitude of the vector is square root 13. Okay? Those double bars are not absolute value. They're the length of the vector. Magnitude. Cool? Okay? Scalar is a constant that you multiply a vector by. Typically it's multiplication. Yes, question?
Where did the square root of 13 come from?
So if you were to graph this, it's right 2, because the first part is horizontal, and up 3. The magnitude of the vector itself, v, then, is neither 2 nor 3. It's the result of going right 2 and up 3. So the square root of 13 is how long the vector is. So it's the hypotenuse. You with me? I should have graphed that. Okay? All right. So scalar multiples are layup questions. If I tell you u is some vector that has a horizontal component of -4 and a vertical component of 5, then 3u is just each of those components multiplied by a factor of 3. Think of the whole arrow being stretched 3 times as long. So now instead of 4 negative, it's -12 and 15. Multiply each component by 3. Cool? Okay. So is this the next part? I want to make sure I have these in the right order.
Yep.
Okay, cool. I just talked about 3D graphing. Obviously, I jumped the gun. A vector can be drawn anywhere. It is not necessary to start at the origin, although that is what's called, what is that called? There's a name for that. Original position. I should have looked that up. Sorry, darn it. Vector can be drawn anywhere, not necessarily to draw at the origin. So if I wanted to draw vector u, which is left 4 and up 5, I could definitely put my starting point as the origin and go 1, 2, 3, 4, 1, 2, 3, 4, 5. And that is definitely one possible u. But there is absolutely no reason in vectors you're confined to that situation. You could start over here as your initial point and go left 4, up 5, and it would be the same. Either of these is u. I could start down here and go left 4, up 5. They would all be the same length and in the same direction, but they would start and terminate in totally different points, initial and terminal points. Okay? Now sometimes they want you to put it in a certain position. They want you to say starting at this point and going to this point. So for example, if I told you the initial point, now this is a point, not a vector. The initial point P is 2, 4. That's the starting point to the vector. And the ending point is 4, 1. Then the vector, that I know in geometry we think of that as a ray, but that's a vector. Vector from P to Q, P towards Q, is blank. Well, to get from a point of 2, starting x of 2, to an ending x of 4, we must have gone how much horizontal? 2. Now this is a vector, so you should be using pointing type situation here. What about going from a y of 4 to a y of -1? -3. You could have also done this in, 2i hat minus 3j hat. That's also, it's the same. They're the same. Okay? You done? All right. If I wanted you to graph this, then 1, 2, 1, 2, 3, 4 is the starting point. 4, 1 is the ending point. It should have a point at the start and an arrow at the end, and that is vector Q. That's P in the direction of Q. So far, so good? Okay. Polar to rectangular, converting one form to another. If you converted 4 at an angle of 2, that's 2 radians, to component form, then we need to figure out what are the horizontal and vertical. This actually builds off of yesterday. 4 is how far we go, but first let's turn 2 radians. What quadrant does 2 radians put you?
Second,
Second, why?
because it's less than pi.
Less than pi, but more than
Greater than pi half.
5/2. So it's over here somewhere. Who knows where, but it's there and it's 4 long, yeah? Now, I need the horizontal component. Let's call this, I guess I'll call it A and B. You could also, you'll often see those called V sub X and V sub Y, but let's call it. Okay, how did you find A?
The sine
Sine.
of 2
Sine of 2
times 4.
times 4. Why sine if A is adjacent? Cosine. Okay, so A is
Greater than B.
4 cosine of 2. Does the calculator know the appropriate sign to attach?
No.
No.
It does. 4 cosine of 2 is good to go. And what about the B?
4
4 sine of 2. And so if you were to put this in component form, if I didn't have my calculator open, which I don't, then it would be 4 cosine of 2, 4 sine of 2. And that's the vector in component form. When I put those into my calculator, I would definitely expect negative on the first component and a positive on the second. Yes? Okay. Alrighty then. I will, again, this is not my job to teach you this, but when you get a vector in free space, you actually have to give 2 angles. You first have to say turn this angle alpha to get under that vector, then turn this angle beta to face in that direction, and then have a magnitude. So you have 2 angles at work there. All right. Is this got cut off? Is this next? What does that say? What does that say? CT polar? What does that mean? Rectangular to polar? Is that what that says?
Yes.
Okay, cool. Here we go. Let's sketch helps. This you've been doing since algebra 2, but I just want to make sure you're solid. Wouldn't you say, what quadrant does this put you in? 2, yeah? Okay, cool. We have 2 components to find. The magnitude, or the radius if you like, and the angle. R and theta. Or if you like, actually let's call this, let's use some notation. The magnitude of u, or how long the vector is, total, not just in the x direction and y direction, how long total, and the angle. How do you find the magnitude? Pythagorean theorem. So the magnitude is the square root of 41, did you say? Okay. Do we all agree with that? Okay, cool. Theta. Again, we'll just do this without a calculator, but what do you reckon? Inverse tangent of 5/4. I love that you're blowing off the sun because you don't want the sun. Okay. And then is that it?
No, only when
There's no one. This is calculus, people. Let's see if these.
2 pi minus
Not 2.
pi, you're right.
Okay. So I think you can agree that alpha is inverse tangent of 5/4. I'm blowing off the signs. I just want to know what's the angle in the triangle to get the sign. I don't want to get inverse tangent and the quadrants that's restricted to into the mix. I don't want that in there. I just want what's the angle. You with me? And then the actual polar angle is pi. Remove that. So our angle is pi minus inverse tangent of 5/4. And absent a calculator, that's what you need. Do you see me? Or you feel me, or whatever? You understand? Okay, good deal. Alrighty. All that I think was pretty review. I don't know if you do this in physics. I don't care how they do it in physics. I'm going to do it the way you do it in math. So here we go. Say you're given two component vectors, u and v, and I asked you to sketch the sum. There are two methods to drawing the sum angle and finding the sum. Actually, let's just find the sum. What is the sum of u and v? Yeah, you don't have to show the work, but for no purposes, it's 6i hat and how much j hat? Negative 2j hat. We? Okay. If you were going to draw this, there are two ways to draw this, the parallelogram method and the triangular method. One is to say if you start in primary position or the origin as your starting point, u is right 2, up 3, here's vector u. If you draw vector v also from the origin, then it's right 4, down 5. Follow me? Okay. Now, the goal is to show on the graph what u plus v is. Right? The sum of u and v, remember back in Algebra 2 when you did the resultant vector? The result of pulling this way and pulling this way is pulling somewhere in between, yeah? The result of that is actually a parallelogram. If you were to match this here and this here, and the resultant force, or the sum of the two vectors, this is u plus v. It's the diagonal of the parallelogram. This is u. This is v. You see where I'm coming from? Okay. Another way to graph the sum vector, it really goes to your professor's preference. Sometimes they'll do both. I don't know. It's only one or the other. The other is to graph one, then the other. So if you were to graph u first, 1, 2, 1, 2, 3, there's u. And then from the head of u, you put the tail of v, or from where you just left off, you go v. Think of this like a new origin. From that point now, you're going to go right 4, down 5. This is u, this is v. You follow me? Yes. The sum of those two movements then is u plus v. Where those two vectors, one after the other, take you is the sum of the two vectors. And you get a triangle that way. Either way, you can see that u plus v has a horizontal positive component and a negative vertical. You follow? Doesn't it look like either of those is right 6 down 2? Okay. In polar, it would be so wonderful if you could just say, oh, add these, 7, and add those, 7. But that, of course, is but that's not true. Never has been, never been, will be true. Instead, you need to add the horizontal components and the vertical components. How would you find the horizontal component to the first vector? Cosine. 3 cosine 2. 3 cosine 2 is the horizontal part of the first vector. The horizontal part of the second vector is? 4 cosine 5. Altogether, that's the total horizontal component. I'm using I hat, j hat, but you could use the pointing brackets, that's fine too. Plus, what's the vertical component? 3 sine 2 plus 4 sine 5 j hat. If we have 3 dimensions, we'd be dealing with the k hat also. Are you with me? Okay, cool. Subtracting vectors. First of all, before we graph it, just tell me what is u minus v? If you take 2 and subtract the effects of v, what do you get? Negative 2I hat and minus 2 or plus 8?
Plus 2.
3 minus negative 5 is plus 8. Okay? Subtracting 1 minus the other is negative is positive. You follow? The sketch of this. I'm going to do both from the origin, okay, not head to toe kind of thing. So if I go u is 2, 3, there's u. Starting from the origin with v, it's right 4 down 5. Here's u, here's v. Now I'm going to span the gap to show u minus v. The question is, where's the head go, where's the arrow go? Do I go from v to u or from u to v? Which of these would represent left 2, up 8?
From V to U.
V to u. This here, that's u minus v. Okay, I like to make the calculation first. It's what makes sense. I can never remember just memorizing which one goes where. I just use the calculation. Do you agree that that's the one that makes sense with negative 2 plus 8?
Yes.
Okay, cool. Moving along. Unit vectors in the same direction. Find a unit vector in the same direction. Unit vectors are vectors of length or magnitude equal to 1. Let's think of it this way. Think of this visually here before we find it. This u is left 4, up 5. Here's vector u. Vector u is too long. How long is vector u? How long is it? Square root of? Wow, I was expecting that to go better. It's 4 this way and 5 that way, and you have a right triangle. We use what's called the Pythagorean theorem. Right? Yeah. So the length is root 41. The length is between 6 and 7. Way too long. The question is, yeah, find a vector in that direction, but make it so it's only 1 unit long. How do I shorten it up? How do I keep the direction the same, but make it shorter? Now,
No, you get the angle.
before, back in the scalar part, remember here, when you multiplied by 3, this stretched it or made it longer? Well, how will you make it shorter? Instead of multiplying, you divide. Okay, now, the question is, how do we divide, or what do we divide by? Divide by the length of the magnitude. You want it to be one. Think of it in terms of a similar triangle. You want to divide by a factor of 1 over root 41. What do you divide? Yeah, each of those. By using these again, the direction stays the same. But by dividing by the magnitude, it shortens it up to 1 unit long. If I ran Pythagorean theorem on that, negative 4 over root 41 squared plus 5 over root 41 squared is 16 over 41 plus 25 over 41. You can see it is exactly 1 unit. Follow me?
Wow.
So to get a unit vector in the same direction, you keep the components the same to get the direction going correctly, but then you divide it by the magnitude. Write yourself a note if you need to. Use the same components. divide by the magnitude. Or the hypotenuse, if it helps, if that makes more sense to you, fine, but you're gonna hear it called the magnitude by me. Okay? So, pretty typical calculus vector question. So far we haven't actually even done any calculus, but now we will. Find a vector tangent to the curve, y equals x squared minus 2x plus 1 at x equal 2. Then, and sketch it. Let's sketch it first here. So, if I were to graph this, isn't this x minus 1 quantity squared? So how's that parabola shifted? Right one. All right, so here's the parabola. Here's 2. If I draw a vector tangent to this, and it's like drawing a tangent line to this, except instead of passing through that point, it's just originating that point, and just as if you kept going in that direction you left off. Follow?
Yes.
All right, we're going to do that first. That's part A. And then, once we have that vector, then we're going to find a unit vector to the curve at x equals 0. And so that's part B, yeah? This is it. All right, so how do you reckon we find a vector tangent to the curve? Take the derivative. The derivative of x squared minus 2x plus 1 at 2 is 2x minus 2 at 2, or 2. So far, so good? All right. Now, you take that and you make it a slope, put it over 1, basically. And the reason you want to do that is so that you can make a vector out of this. Now you have horizontal and vertical components. What's the horizontal and vertical component to the slope?
Horizontal ones up.
1 and up 2. So the vector in the direction of that tangent is 1, 2. Horizontal comes first, then the vertical. The vector in that direction is 1, 2. Now, is that a unit vector?
No,
No, but does part A ask for a unit?
no.
No, it doesn't. So you're okay there. That's your answer. And we're good with part A. So far, so good? Okay. Part B. Unit vector tangent to the curve at x equals 0. Now, this has 2 components to it. You need to find a vector in the right direction of the tangent, but also then you need to shorten it up so it's 1 unit long like we did there. So let's start with the derivative again. What is the derivative at 0?
Negative.
Negative 2. Okay? So this vector wants to be negative 2 over 1. If I put that in component form, is that negative 2, 1 or 1, negative 2?
1, negative
1, negative 2. Question, do I have to put the negative on the 2? Could I put the negative on the 1?
2. No.
If I put the negative 1 on the 1, wouldn't it be a vector like this? And is that also tangent to the curve? Yeah, there are 2 answers. Either one is fine. Okay? All right. Now, I think you'll agree that that vector is too long. How long is that vector?
Root 3.
It's root 5, yeah? Okay, so according to the previous example, how do we shorten it up so it's exactly 1 unit long? Divide by the magnitude while keeping the components otherwise the same. So 1 over root 5 and negative 2 over root 5. And if I check that by Pythagorean theorem, the magnitude should be. Cool? Okay.
Why was it 1, negative 2?
When you did the slope, do you agree with the derivative being negative 2? Okay, now that, if we think of that as a slope as rise over run, then that's going either up to left one, the vector I actually drew, I drew it the wrong way. But it's either up to left one or down to right one. And so as far as these numbers, they have to be 1 and 2, but the negative could be on either one. Okay? All right. Unit vector normal. Normal, what does normal mean in calculus? Perpendicular. Now, vectors you don't say, this is what, I just say this just for fun. In vectors you don't say normal, you say orthogonal. Orthogonal. I just love to say orthogonal. Perpendicular, normal, and orthogonal all mean the same thing. Typically you say lines and planes are perpendicular. You say a vector is normal to a curved plane, and two vectors are orthogonal to each other. Orthogonal, but think perpendicular for all of those. They, in essence, mean the same thing. Later on in Calc 3, you'll get surface integrals, and you'll do stuff like this, and you'll find either a plane perpendicular to this, or a vector perpendicular to this. That's all for your Calc 3 teacher. But it's pretty great stuff. It's really hard as heck to draw, but it's really cool. All right. If I asked you to find two vectors orthogonal to 5, 2, let's start by sketching vector u. 1, 2, 3, 4, 5, up to. If I put it in standard position, starting at the origin, then that's vector u. Cool? Okay. There are two possible perpendicular vectors. What's one perpendicular vector? I mean, couldn't I go this way here?
Yes.
That's one, or
Yeah.
that's two. All right. I'll call this, let's call vector v1. How would you achieve vector v1? Think of how you do slope. When you do perpendicular slope, what do? Flip and change the signs. Now that's the signs all together, so you don't change both signs, you only change one sign, yeah?
Yes.
So, first of all, I think you'll agree that instead of going horizontally 5 and up 2, we're going to go horizontally 2 and up 5. But we also need to switch the sign. Now, vector 1, which is it switching, the 2 or the 5?
2.
2. We were now moving left and up. So that's, vector 1 is a possibility of negative 2. What about vector 2?
Negative
2. Okay, now I actually lied to you just there. I said there are two vectors perpendicular. There are actually more.
4.
How many? Infinite. What kind of? Why infinite?
Much as what you want to.
Yeah, if you take this as a vector and keep it as a right angle, isn't it just all the perpendiculars would actually form a disk of perpendicular vectors. So there are many. All right, if you don't limit yourself to 2 dimensions. All right, find a unit vector normal to y equals sine of x at pi, x equal pi over 6. Gosh, lots going on here. We got your normal, we got your unit vector. What do we do? And we got a function. What do you reckon we should do?
Slope, derivative.
Slope. So let's start by finding the tangent. If you take the derivative of sine at pi over 6, what is cosine of pi over 6? Root 3 over 2. Cool. All right. What's the normal to that? Negative 2 over root 3, yeah? Now all that's slopes. Now let's change it to vectors. What's a vector that's normal? Okay, this is your rise, and this is your run. So which one is your horizontal? When do I click first, the 2 or the root 3?
Root 3.
Root 3 comes first, okay? And the vertical is 2. The sign could be on either, actually. Negative on either one, but it should be on one of these, not one. So far, so good? Am I done? Circle it.
Divide by root 7.
Yeah, this is too long now. To make it a unit vector, we need to now divide by root 7, you say? Do you all agree? Okay. What if your answer wasn't there? What if you Didn't see that combination. What's another possibility?
They simplify.
They could simplify. I was thinking more like sign. What's another sign combination?
Negative root 3 over root 7 is the 2 root 7.
Yeah, that was the negative on that horizontal component. Okay. All righty. Now, sometimes instead of a unit vector, they want you to shrink it down. So a little something like this. Find a vector of length 3 in the same direction as 5, 2. You first find a unit vector, then stretch to length 3. So what's a unit vector in the same direction?
So root 20 over root 29.
5 over root 29.
2 over root 29.
Okay, now how long is that vector?
1.
That's 1 unit long. What do we want our vector?
Multiply factors.
We want it to be 3 units long, so we're going to multiply by a factor of 3. Which one? Both of them? Yes, both of them. 15 over root 29 and 6 over root 29. So first shrink it down to 1, then stretch it out to 3. Understood? Okay. Last but not least, this is probably as ugly as you'll see, at least in Calc 2. Find a vector of length 3, normal to the curve, at x equal 1. A lot of steps here, but just take it step by step. What should we do? Take the derivative. All right, now that's going to be a tangent calculation. Dy dx at 1 is 6x squared plus 1 at 1, which is 7. Yes? Did I make a mistake? Are we good? Your silence is scaring me. Now make it a fraction. 7 over 1. Now we could either, now let's go to normal. What's normal? Negative 1/7. Now make it a vector.
Negative 7, comma 1.
Either negative 7 comma 1 or
1, comma 3.
Or
7, comma 2.
7 negative 1. 7 has to be first, 1 has to be second, but the negative could go on either one. Down.
Divide by
Okay.
root 50.
Now let's make it a unit vector by shortening it up. Negative 7 divided by root 50. 1 divided by root 50. And now let's stretch it out. What do we multiply by to make it a length 3? 3. So we get negative 21 over root 50. 3 over root 50. If I had the time, I could do a Pythagorean theorem on that, but it better be 3. Follow me? Okay. All right. Let me give you a couple answers to the homework, but if we don't get through it all, so be it. We'll finish it tomorrow. Number uno. Number uno. Am I going to get this? Oh, shoot. I'll tell you what, I'll post the answers to this on my website, and you can check it over and turn it in tomorrow, okay?
Okay.
Have a lovely day. You can turn it in if you want.
No, it's just normally when we're like, no, we're gonna end this discussion right now. So.
Yeah, I'm just tired. I'm so tired.
And it's really, really nice about
Do my questions stress you out?
no, it's just that.
It's just go, go, go.
Alright, this is really difficult in the bell and it's very stressing.